Have you ever heard of ghost particles? They're called neutrinos, mysterious particles that pass through us in unimaginable numbers every second without leaving a trace. And new research suggests these ghost particles might be coming from an unexpected and powerful source, supermassive black holes. In today's video, we dive deep into the latest findings on how blazars, a type of active galaxy, could be bombarding Earth with these elusive particles. At the center of most galaxies, including our own, sits a supermassive black hole. When these black holes actively feed on surrounding material, they create what's known as an active galactic nucleus, or AGN. But some of these AGNs take it a step further, shooting out powerful jets of radiation and matter at nearly the speed of light. When one of these jets is pointed directly at Earth, we call it a blazar. Blazars are like cosmic cannons, aiming straight at us. And these intense jets could be creating neutrinos, strange particles that are almost impossible to detect. Neutrinos have no charge, almost no mass, and can pass through planets, stars, and even humans without leaving a mark. In fact, 65 billion neutrinos pass through every square inch of your body, every single second. That's why they're often referred to as ghost particles. But why are they important? Neutrinos can pass through dense cosmic objects that even light can't penetrate, making them valuable tools for probing the universe. So, how do these blazars create neutrinos? It all comes down to gamma rays. Blazars are a subclass of AGNs, and they emit highly energetic particles known as cosmic rays. When these cosmic rays collide with photons, or particles of light, they can produce neutrinos. Gamma-ray flares from blazars have long been suspected of being the source of the neutrinos we detect on Earth. The link between blazars and neutrinos was first hinted at in 2017 when a high-energy neutrino detected by the IceCube Neutrino Observatory, buried deep in the ice of Antarctica, was traced back to a blazar named TXS 0506+056, located 5.7 billion light-years away. This was a major breakthrough. It showed that the flares of these blazars could be the source of high-energy neutrinos. But the full relationship between the amount of neutrinos, known as the neutrino flux, and the blazar flares remained a mystery, until now. An international team of researchers decided to dig deeper. They analyzed TXS 0506+056 and 144 other blazars from the Fermi Large Area Telescope monitored source list. They focused on how often these blazars enter a state of intense gamma-ray flaring. This was called the flare duty cycle. The flare duty cycle essentially shows how much time a blazar spends in a flaring state and how much of its total energy output comes from these periods. The researchers found something surprising. Blazars with lower flare duty cycles and lower energy fractions are more common. They exhibit a pattern called a power law relationship, where a change in one variable proportionally affects another. By understanding these patterns, scientists were able to make better predictions about how many neutrinos each blazar produces and when. They compared these predictions with actual neutrino detections from IceCube over short and long periods, helping them set upper limits on how much these gamma-ray flares contribute to the neutrino flux. These findings are just the beginning. With more precise measurements and new methods, we can refine our understanding of how much blazars contribute to the overall neutrino population in our universe. This could have huge implications for our understanding of the cosmos and the extreme processes happening around supermassive black holes. Future telescopes and observatories, both on Earth and in space, could provide even more data, helping scientists unlock the secrets of these powerful cosmic phenomena. The hope is that by studying blazars more closely, we can solve the mystery of the origin of astrophysical neutrinos. So what does all this mean for us here on Earth? While neutrinos from blazars pose no threat, they do offer a unique window into the most extreme environments in the universe. The research into these ghost particles will help us understand the most powerful engines in the cosmos, supermassive black holes, and how they shape the galaxies around them. What other cosmic secrets are waiting to be unraveled? Stay tuned and keep watching to find out.